Hello everyone, I Rahul Sinha on behalf of our Group 3 welcome you all to our DIY project. Our team members are navaneeth Shaji, Raghav Aggrawal, I Rahul Sinha and Shashwat Kushwaha. For our project we have developed a Morse code translator, and to begin with let's have a look on the schematic of our project. The user can give input in form of actual text or Morse code in form of dots or dashes, which is then, after receiving the input, the string is converted into Morse code using the uploaded code in Arduino. After this, the Morse code is transmitted via the LED or laser, as you can see here, which is then received by the photoresistor, and after accepting the signals, the Morse code is converted into text, which is then finally displayed on a monitor or LCD screen. As you can see, we have assembled the breadboard, which here is the breadboard, here's the Arduino, here is the LED, this is the laser, these are the jumper cables, and here you can see a potentiometer. This is the photoresistor, this is the LCD display on which the output is displayed. This is the second Arduino, and this is the breadboard.
So this is a code which does the string to Morse conversion. I'll quickly run you through the code. So initially we have defined a string called code, which will be passing through this function here. Now this function, what it does, it will acquire each letter as shown in this line, and it will run a check through each of these letters that we have given, and if any letter corresponds to one of them, then an array is filled with the following numbers as binary numbers to show each of these letters. Now the process that we have implemented follows one uniform structure, that is, we implement each array as binary numbers to showcase each of the letters. So every letter which is made of dots and dashes will be represented in the form of zeros and ones, where 0 corresponds to dots and 1s correspond to dashes. So in that format, every letter is being converted into dots and dashes and being stored into the array. And this function will be doing that. After that part is done, another function is used in order to transmit them using the laser. So again, the string is accessed in this function, and each of the letter is being each number that is there in the Morse code will be displayed using the laser by turning it on and off. Simultaneously, it is being printed on the serial monitor as well in order to check the accuracy. So this is the setup part of the code, where we have assigned pin 4 to the laser, and also initialize the serial monitor. And on the void loop, we have given a code to input the string from user and also check its length, so that we can assign an array of integer type called Morse, where we will be storing the binary numbers. Finally, it's just calling the functions, and the code will work on its pipe. So that's all. The second part will be explained by Raghav.
Hey, I'm Raghav Aggrawal, and this is the code to convert the signal from LED to a string. So in this code, this is the white setup to set up the LCD and photoresistor. After this is the main while loop, and this while loop takes the input from photoresistor till it gets a signal to terminate, and this is the light is the data which we are getting from photoresistor. In this, what we have done is we have taken 150 as a benchmark. Like if the photoresistor reading is more than 150, that means the LED is turned on, otherwise it is turned off. So here this represents if the LED is turned on, we are measuring the time or the duration for which the LED is turned on. If the LED is turned on for less than 2 seconds, then we are considering it as a dot. And if the LED is turned more than 2 seconds and less than 4 seconds, we are considering it as a dash. And at the end of every communication, to show to get the communication is over, we are turning the LED on for more than 4 seconds so that the user know that the communication is over. So here when the light would be turned on more than 4 seconds, it would get 4 in the array, from which we will know that the communication is over at this point. And here we are measuring the time for which the LED is turned off. So if the LED is turned off for between 2 to 4 seconds, that means it's a dash between two characters. Like if we are writing H high, so for 2 to 4 seconds it would be a gap between H and I. And for 4 to 7 seconds it would be a gap between two letters. Let's say IIT KGP, so it would be gap between IIT and KGP would be 4 to 7 seconds. So by this function we would convert the LED data to an array, and later we will convert that array to a string from this function array to Morse, and this function is written up here, array to Morse. In this function we will simply convert that Morse data to a string. For that, first we will convert the zeros and ones into integer. After converting that, we will call a function in which print it, which would convert into a string, which is here. In this, for every character, it is represented by a special Morse code. So when it finds a 0, 1 in the array, it would represent A. If it's a 1, 0, 0, 0, it would be P. So similar to this, there are each unique characters for every letter in the alphabet. So by this would convert the array into a string, and later it would print on the LCD screen and the serial monitor. Thank you.
Hello everyone, my name is Kushwaha and I am going to show you the practical demonstration of our project. Here, as you can see, we are entering the input string IIT into the terminal window. And now, the Arduino code embedded will try to convert the string into Morse code, which will be received by the laser. And the laser is sending the signal to the other end, the receiving end. There, at the receiving end, there is an LDR sensor which will detect the light coming from the laser. It will detect the Morse code. Here, as you can see at the terminal window, the LDR sensor is detecting the Morse code. Once the complete Morse code is received by the sensor, the code embedded in Arduino will start converting the Morse code into string characters one by one. Well, due to the low brightness of the LCD panel, the output characters that we are going to show were not visible clearly. That is why we prompted out the characters that were appearing on the panel. As you can see, one by one, all the characters are being printed out in the panel as well as on the screen. Thank you for watching. Hope you liked our project.